Thanks, Kara. Appreciate it. Hi, everyone. I'm Yevgeny, founder and CEO of CloudQuery, currently based in New York. Happy to walk through the session. Jason, back to you.
Hey, y'all. My name is Jason Cow, Head of Security Research and Solutions at CloudQuery, currently based in Raleigh, North Carolina. I'm pretty excited to be here as well with Yevgeny.
All right. Cool. So let's get started. So let's go to what we will talk about today. So just as a quick recap, CloudQuery is an open source ELT framework. You can find also our GitHub repo at github.com/CloudQuery/CloudQuery. What we're building or what you can do with CloudQuery is actually build plugins on top. So any plugin you build on top of CloudQuery, you can sync that data to any database like Postgres, Snowflake, or Data Lake, and kind of have CloudQuery as the first layer in your ELT stack or modern data stack, which we'll talk about. But now back to maybe some kind of enterprise solutions and use cases that you might be familiar with. So if you're a platform engineer, DevOps engineer, or an SRE, you probably had the chance to either build or buy asset inventories, security solutions like CSPM or CNAPP, FinOps solutions, SOC 2, and kind of the thing that is common to all of them is really that they all work on the same data, but they are all actually different solutions. So you have this sprawl of different solutions with different vendors most of the time, with different dashboarding, different query languages that you need to learn all of them and sometimes integrate like use cases and automation between them. While all of them do actually share work on the underlying same data and same APIs. So what we want to propose and go through is to change a bit the approach to solve some of the use cases. So what we'll show today is how to solve those use cases with kind of modern data stack approach, where we've kind of combine all the data into one database or a number of databases. So we combine the data with CloudQuery, where we right now CloudQuery, our team maintains official connectors to GCP, Azure, Oracle, and a bunch of other cloud providers, AWS, of course. And then you can bring all that data to any of those databases pretty fast. So it's all written in Go. And then you can connect kind of all that data to your favorite visualization tool, Grafana, Metabase, Neo4j. For the purpose of this talk, we'll go through that specifically. Neo4j UI for graph and visualizations. So in that approach, you kind of can solve those use cases with a single stack. And you'll have and we'll talk about some of the advantages, but obviously you eliminate the data set silos that we had before, kind of eliminate some of the needs to query, to learn 4 or 5 different tools or dashboarding on query languages, and kind of really consolidate some of that. So we can go to the next slide. And I can pass it on to Jason to talk about some of more specific use cases about AWS and Neo4j specifically, and some of the interesting use cases we can solve with Neo4j.
Yeah, definitely. Thanks, Yevgeny. So one of the things that we realized while growing our product and looking at CloudQuery and some of the use cases, that there's a lot of infrastructure sprawl across cloud service providers. When we went through this was a while ago, we noticed that there's 1,400 plus list APIs in AWS. There's over 1,400 plus APIs in GCP, a lot in Azure as well. And on the right side of the screen, we just pulled some documentation from one of the AWS services, right? So as you may be aware, AWS has over 200 plus different services, including EC2, EC2, one of the things that we've noticed is that it's sort of an umbrella service for not only a standard EC2 instance, so take your basic VM, apply it to cloud. It's also a service that covers networking, other things as well. And that's what you see on the right is network ACLs, NAT gateways, local gateways, etc., launch templates, key pairs. These are all things that cross over from EC2 all the way to networking. So when we look through this, right, on the screenshot on the right, which is just a small snippet of the APIs they have available, there's a lot of different data types across EC2, and that's only one of 200 plus services in AWS. And we notice this with a lot of infrastructure sprawl. Throughout this talk and a couple of examples we'll give later on a somewhat live demo, we'll talk through a couple examples, and we'll talk about how, you know, deploying a resource in cloud, specifically from an infrastructure perspective, is not as simple as it seems, right? One of the things we notice is, like, you know, deploying an S3 bucket, it may take multiple different types of resources. The examples we'll use include KMS, KMS, which is AWS's encryption service, RDS, which is AWS's relational database service, where you can host Oracle DBs, other types of databases as well. And they also have like a serverless offering called Aurora. And we'll also look possibly at some networking related to that, right? And that's, you know, where some of these resources and relationships come into play. So one of the things to realize with infrastructure data, and before I move on, I do want to mention that we do support multiple different types of sources. This isn't, I think in the description we talked about, we're talking mostly about cloud providers, but we also see different resources from, let's say, GitHub, Bitbucket, Cloudflare, other resources or other platforms that companies may use. Because at the end of the day, right, trying to visualize all this information can be very difficult. And as Yevgeny mentioned, using that infrastructure data lake approach instead of having very siloed approaches or siloed solutions where the data may not play nicely with each other, we're looking to normalize that data and provide it in one singular database where visualizations, relationships across the board can be drawn. And one of the reasons why we look specifically at Neo4j, and we'll allude to this a little bit on this slide, is that we added support for Neo4j as a destination for better visualization to help solve for many different use cases. We saw security, infrastructure, engineering, support, and more. We actually have a few resources here where we do something called attack surface management with graph databases using Neo4j, and also information about the Neo4j plugin. So that being said, we alluded to this a little bit earlier, is what happens when a dashboard isn't enough. As you may be aware, a couple of years ago, and fuzzy on some of the details here, in terms of specific dates and timelines, when cloud computing first came out, cloud vendors came out with cloud security posture management, other tools throughout the market to manage cloud security at scale. These include things like CSPM, so cloud security posture management. You may have heard of something called asset inventory, basically taking inventory of what people have deployed. Asset inventory helps with things like shadow IT, resources that may be orphaned, may not be used anymore. But a lot of use cases, including cost optimization, asset inventory, cloud security, infrastructure, platform teams, all play nicely with CloudQuery. But what we realized was that a dashboard, certain queries provides very flat information, which is useful for a lot of simple things, right? So is my S3 bucket, using a common security example, is my S3 bucket public? Does it permit access to something that I may not want it to permit? Is my EC2 instance or my EBS volume, so the block storage device attached to my EC2 instance, is that encrypted properly? Are my resources encrypted properly? Are some of my resources default public? AWS has settings at the account level for block public access for a couple different services. So are those settings turned on? Are those turned off? What do those counts look like? And those are all very, I would say, flat queries or flat things that we can look through with a very simple database. Or a very simple dashboard. However, given the complexity of cloud, there are quite a few use cases where that doesn't help as much. For example, we'll take an EC2 instance, right? I spin up an EC2 instance. I may actually spin up 14 other resources with the EC2 instance just to have it there. I could spin up a key pair. I may need an EC2 instance profile that may be mapped to an IAM role, that may be mapped to multiple managed policies in IAM. It could be mapped to an EBS volume. The EBS volume could be mapped to a KMS key. Again, I could have EC2 user data as one of some of the attributes. I could have security groups, and then to check if there's network access or not, I may need to look at my VPC, which is a core networking construct in AWS, and look for, let's say, an internet gateway to see if there's public, access or not, public subnets, private subnets, the route table, and the list goes on, right? And we can even get more into the details and into the weeds of saying, okay, is this an enterprise solution? Or is there a transit gateway that may allow access, right? Do I have certain types of VPC peering? Am I using a shared VPC across different accounts? Do I even have, let's say, VPC endpoints deployed in the account? And what does the internet access look like across the board? All these queries are difficult to solve with just a very simple dashboard and require a lot of pulling and playing with relationships across the board. So from a data perspective, we look at how do we link these resources together and how do we draw these connections between resources to really show what's important. And that's what we alluded to attack surface management earlier. And one of the reasons we talk about attack surface management is because attack surface management is a common security, is a security use case that focuses a lot on trying to find what's important and trying to map attack surface. From mapping attack surface, right, that may look like, okay, I found a public EC2 instance. Does that have access to an S3 bucket, or does it have access to sensitive data via the IAM instance profile? Some of these queries, some of those questions, right, are better solved by graph relationships. And we'll show you some of those examples in a little bit. So we talked about that. We'll use a couple more simple examples today. One of them is identity and access management. I apologize for the acronym here. But one of the things we notice, right, is from an IAM perspective, we'll start with a query, like the simple use case of maybe I'm using an old AWS account. And I no longer want to use IAM users. I may also want to figure out, hey, how do my IAM users gain permissions? And in this case, in AWS IAM, and I'll do a brief introduction of that and not spend too much time there, we have multiple different ways of gaining access or gaining permissions in IAM. That includes managed policies directly attached to the IAM user. It includes inline policies that are actually part of the IAM user itself. It includes IAM managed policies attached to the group that a user may be part of, as well as inline policies on the group itself. So just by thinking about IAM users and access, there are 4 distinct methods of giving access via IAM to an IAM user. And this actually goes further than that. If we want to really deep dive into this, where I can look at resource-based policies in AWS and say, for example, does my S3 bucket policy grant access to the IAM user? Does my KMS key policy grant access to the IAM user? And these are all different ways of past those 4 initial use cases or 4 initial points of how do I grant access to my IAM user? In this case, as you may be aware, IAM users may be attached to long-lived access keys and long-term credentials. And in this case, for this example that you see on the chart or on the screen today, we're also looking for, are there access keys attached to these IAM users? And we'll show that in a little bit as well. Another use case, the one that we alluded to earlier about RDS. So RDS is Amazon's relational database service. We're looking at RDS instances in this case, and we can tie resources such as EC2 security groups, AWS KMS keys. And before we dive a little bit into more of this encryption piece, there are 4 different types of resources we look at within AWS KMS. There's a KMS key itself. We also look at KMS key aliases. So those may be friendly names for the KMS key where they may have a jumble of characters and numbers that may not be human recognizable. We also look at the KMS key policy, which is a main mechanism in AWS to grant access to a KMS key. And lastly, we also look at KMS key grants, which is a underappreciated method of gaining access or granting access to a KMS key and possibly data related to that. From a networking perspective within RDS, and we'll do this real quick as well. Again, we mentioned security groups. We're going to look at VPCs as well as internet gateways and try to see what those relations may look like in RDS.
And
so that being said,
I think also, yeah, sorry, go ahead.
That being said, we'll switch over to one of our live demo, and we'll show just some of the pieces behind what this may look like. So right now I have Neo4j just running locally, and you'll also see a terminal window. So typically what we run for just syncing our data from, let's say, for CloudQuery from, let's say, AWS, is I'll actually sync CloudQuery sync aws.yaml, neo4j.yaml. And what this does is it pulls information from AWS using our simple configuration files that we have drawn up in like the aws.yaml file and the neo4j YAML file. And I'll output that information all to Neo4j in this specific database here. So I can run that. And you'll see it's doing a little bit of processing. We can actually go through and skip a little bit of that. Let me pull up something else. So once this successfully runs, what we'll do is we'll go through and do a couple things and just pull some simple queries and demos through here. So the first thing we'll do is we'll just do a simple match. I'm user access keys, return n. And what you'll see here is there are currently in this database, there are 5 user access keys there. What we want to do, to connect these, there's currently no relationships, is we'll try to do a relationship between the IAM user nodes and the IAM user access key. One of the things we're looking at is, helping out our customers and building some of these relationships using the power of Neo4j. So we've had questions about, are there, pre-populated relationship things that we can run to basically create some of these relationships, given our knowledge and our familiarity with AWS. So I'll quickly put this in and run this. And what you'll see here is we're creating this relationship between IAM user access keys and IAM users, where we're saying, IAM users, does it have an access key, and create that relationship there. So if I run this again, one of the things here we can see is now we can see that there are users that possibly have these access keys there. To continue down this path of IAM, we're going to create a relationship between IAM users and IAM groups. So what we'll do is run another query to create that relationship. And I'll go through some of these a little bit quickly. This one has no changes because we don't have any IAM groups IAM groups in this specific use case or in this specific demo environment. And I'll just run through some of the other ones real quick. Again, all this is available online. So if you're interested, we do have the link. And you can follow along with this with our how-to guide. We'll do attach policies. Again, we're going through those 4 specific relationships for IAM users and possibly permissions that may be granted through either a managed policy or inline policy. And the last one we'll do is the relationship between groups and their inline policies. And now what we'll do is we'll just look at our IAM users real quick. It's a little bit different than what we have, but what we'll see is within this read-only, and it's a little bit different from the example because it's a different demo environment. We'll see it does have an attached policy, and it also has an access key specifically for this read-only user. So through there, we can also do, let's say I can look at RDS instances, KMS keys. So I will go through and actually match. Let's go through and look for KMS keys real quick. Want to make sure if this environment is the right one. So we'll see we do have a couple KMS keys, and we'll also look for if we do have RDS. If this environment does not, we probably won't run that query, but feel free to follow along with the guide that we have in your environment as well. We also welcome feedback, and also, happy to hear any current implementations or use cases you may see and how to create those. So we don't have any RDS instances, so we won't do that. But what we can do is we can look, and I'll do this real quick, is looking for possibly KMS key grants, as well as any possible, let's say, access that we can see from there. So we do create a KMS key grant. Again, that's an underappreciated way of granting access to KMS keys outside of KMS key policies. And the last thing we'll do, just to look at this quick example, is to look for KMS keys. And as you can see on the left side, these are all the tables that we've pulled with CloudQuery, and it basically matches up with the data type as well as a service from AWS. And now if we look at this example, we'll be able to see that there should be at least one that has a key grant that's been granted. And in this case, it's been granted by backup, which is an AWS service that does automated backups across the board. But in this case, it needed access to our KMS key. So we've now gone through two examples of basically using Neo4j and CloudQuery to visualize infrastructure data. In the demo environment, there wasn't too many possible queries there. We had a very limited set of information. But throughout, right, we showed how to use CloudQuery to pull infrastructure data, create the infrastructure data lake, and on top we used Neo4j to visualize and query specific things such as how do we link our KMS key access, how do we look at our IAM access, and also if you follow along with their use how-to guide, how to link networking, encryption to some of our databases that we may have in AWS. If there are any questions, here's our contact information as well as CloudQuery's website, and we appreciate your time today.